Hi, my name is Lillian Klein. I'm a research librarian at Statistics Canada. Thank you so much for listening to our presentation. So using blockchain to authenticate data from the Statistics Canada website. This project explores new methods for allowing users to authenticate data from the Statistics Canada website. And our goal was to investigate how Statistics Canada could use blockchain to authenticate the document. So the research team is myself, Catherine Fedchun, who will introduce herself later, and Didem Demirag, but we also were heavily assisted by both Mathieu Laporte, who is the director of the Dissemination Division at Statistics Canada, and Jackie Luffman, the Chief of Publishing Services at Statistics Canada. This project was a culmination of work that began in March 2021. Mathieu Laporte, the director of the Dissemination Division, was looking to research how this division might use NFTs or kind of a similar technology to authenticate products leaving the website. I was asked to research the topic and make connections with academics outside of Statistics Canada who might be able to assist with answering our questions. Thankfully, Jackie was able to make an introduction to Dr. Florian Martin Berteau from the University of Ottawa, who opened many doors for us and assisted us in organizing many meetings with different Canadian blockchain experts. Specifically, I would like to thank the expertise of Dr. Jeremy Clark from Concordia University, Dr. Victoria Lumia from the University of British Columbia, and Dr. Tracy Loriot from Carleton University, all of whom really helped to shape this project into what we are presenting today. So the main focus of this project is to understand more about blockchain and to see if we can expand on the StatCan website and use blockchain technology to enable users to authenticate the data downloaded from the website. With an increased understanding of these emerging technologies, this initiative aimed to develop a process of authentication that would allow users to verify that the material downloaded from the Statistics Canada website has not been tampered with and was produced by Statistics Canada. This would increase the overall trust of StatCan as a statistical organization, and by using blockchain to determine the authenticity of our data, StatCan has the ability to really increase that social trust with its users. It was identified the ideal method of authenticating the data should be easy to use and available in both an online and offline format to ensure that users with varying degrees of internet connection all over Canada would be able to authenticate their data.
Hi, my name is Catherine Fedchun. I also go by Kate. I'm a second year PhD student at Carleton University in the communication department, and I am a research assistant on this project. Our main research question is, how do we leverage emerging technology such as blockchain to increase users' trust in Statistics Canada's products? We also have 3 sub-questions. What is blockchain and how have other government agencies and organizations used this technology? How can this technology be used to increase record keeping, confidentiality, trust, and authentication on the Statistics Canada website? And how can we use this new technology in our solution to authenticate data? My first assignment in this project was to conduct a systematic literature review to answer the research questions mentioned previously. So here's a brief summary of that work. I began by providing an overview of cryptography and blockchain, as this technology has not been utilized before in Statistics Canada. I then looked into how blockchain could increase our record keeping, confidentiality, trust, and authentication. Then I looked at multiple examples within Canada of blockchain being used. And next, I will overview the call to action, causes for concern, and the 5 blockchains we reviewed. So while conducting the literature review, I found that many academics are calling on the Canadian government to move towards using new technology such as blockchain to better secure their data. In a policy book published by the Mowat Centre for Policy Innovation at the University of Toronto, they wrote that government agencies such as Innovation, Science, and Economic Development Canada, the Treasury Board Secretariat, and the National Research Council of Canada were working with blockchain technology. Blockchain is beginning to be used by multiple levels of the Canadian government, including the Government of Ontario, the City of Toronto, and the Government of British Columbia. Healthcare in Canada has also begun to use blockchain to store digital healthcare records securely. This technology can help the government improve transparency, security, trust, efficiency, and effectiveness. By creating a tamper-resistant and resilient repository for public records using cryptography and blockchain, the government can better avoid data leaks, data loss, and other vulnerabilities. Our project will keep the hashes of the documents, which will be used to make sure the documents have not been tampered with. While conducting the literature review, I did come across 3 causes for concern regarding this project: environmental impact, public image, and potential backlash, and an overall lack of regulation. As most of you probably already know, in terms of the environmental impact, some blockchains, such as Ethereum and Bitcoin, consume a surprising amount of energy when completing transactions and generating new blocks. In the next slide, I will go into why we have chosen to move forward with Avalanche. In terms of public image and potential backlash, most of the backlash regarding blockchain, such as what happened to Kickstarter, has focused on environmental impact, which we have addressed with Avalanche. And finally, due to the decentralized and unregulated nature of blockchain, we are using other Canadian government blockchain projects as a guide to mitigate this concern. For this project, we chose to evaluate and compare 5 different blockchains regarding some specific considerations. We chose to look at Ethereum, Avalanche, Cardano, Hyperledger, and Solana. All of the blockchains listed here have advantages and disadvantages. Upon reviewing these 5 blockchains, we have decided to use Avalanche for this project. Avalanche is an open source proof of stake blockchain with the highest transaction rate per second at 4,500. Additionally, it is a public network that is carbon neutral, which are both important considerations for us.
Hi, my name is Didem, and I'm a PhD candidate at CASC at Concordia University. I'm a technical consultant on this project. Now, I will explain you the technical solution. There are 2 main concerns that we aim to address in our solution. The first one is to make sure that the document that the user downloads from StatCan's website actually belongs to StatCan, and we use digital signatures for that. And as for the second concern, we want to make sure that the data is not tampered, and we use hash functions for this purpose. We offer 3 potential solutions to address the previous concerns. While I'll be happy to provide you with more details about the other solutions in the Q&A session, at this part of the presentation, I would like to explain the hybrid solution and why we recommend using it. Hybrid solution provides a comparable usability level with the online solution. And just like in the offline solution, the user does not have to be online in order to check the document they have. We also incorporate blockchain into our solution, and we call it the Hybrid Solution Plus. We aim our system to be accessible to users with different levels of technical skills. Let's have a look at our system design. As you can see at the setup phase, the hashes computed over the documents that StatCan generates are logged onto the blockchain. Blockchain offers provenance of our data for a longer time. And the user downloads an app from the StatCan's website, and the user interacts with this app to authenticate a document. The app pulls the list of hashes from the blockchain every 3 days in order to keep the list of hashes up to date. When we look at users' experience with this app, they just have to drag and drop a file that they want to check into the app. The app computes the hash over the file and compares it against the list of hashes in order to determine its validity status. And there's an additional step for the user to follow if they try to check a document whose hash is not already on the list. In this case, they also have to provide the signature file that has the signature or the hash of the document they have, so that the authentication can be performed. We believe that this solution improves trust and transparency with the users.
So thank you so much for listening to our presentation. We really look forward to any questions you might have about it, or any comments, anything at all. And if you aren't able to ask us any questions after our presentation, please take our contact information and send us an email or connect with us, and we'd be happy to chat about the project. Thank you so much.